Okay, so but a number of you did go for B and C. The A is the right answer. Anyone want to explain why the A is the right answer?
Yeah, I wouldn't mind. Yeah, so the standard deviation is given by two standard deviations determines 95% of the basically 90% of the data. And so if we go two standard deviations above the mean and two standard deviations below the mean, that's going to be our range to include all 95% of the measurement values.
Oh, great. Thank you very much. Under normal distribution, 95% of values are approximately within two standard deviations of the mean. So the mean being this, and so adding two standard deviations is 26.6, so 67.5 plus 26.6 gives us 94.1, and 67.5 minus 26.6 gives us 40.9. We have a range of values on a number line, and then we have slices of the curve above it, and the curve takes on this shape. We know the characteristic of that normal distribution is that 95% of approximately will have a systolic blood pressure and a value within two standard deviations of the mean, in this case between 40.9 and 94.1. So that's it. Values on the number line and chunks of a curve above it. Everyone's underneath this hood, and so everyone's underneath the hood, and we're just interested in getting chunks of this curve through a process of standardizing to a z-score and then calculating a probability. All right, so to try to keep it as real, here are numbers I've got online from the American Heart Association. Ultimately, what we're doing here is just summarizing our data even further by calculating their probabilities, but we can call them percentages for now. We haven't got the probability yet because probability is a branch of mathematics, which we'll start looking at tomorrow. And so probability is a mathematical term. Proportion of probability is going to be the same value. And then we want to multiply by 100, make it a percentage by multiplying by 100. I use those terms interchangeably, but tomorrow it becomes more firmly a probability is a mathematical concept. Yeah, diastolic is what we're looking at. For normal, elevated, considered high blood pressure. So I try to tie my questions I asked to these numbers here. What is the proportion or percentage of adult Americans having a diastolic blood pressure less than 80.8, which is considered approximately normal, not the normal we're talking about, not the normal curve, the normal values. I used 80.8 because it's one standard deviation above the mean instead of 80 because I want you to make use of the empirical rule that we just described. 68% of values within one standard deviation, 95 within two, and also it being a symmetric curve to quickly answer this question. So if you're in an exam or even in your homeworks and you were asked that question, to build up your understanding of this, it's elbow grease. Draw out the curve. If you're a visual person, that helps. Mark off 80.8. Mark off the standard deviations. One standard deviation, two standard deviations. You learn to roughly mark them off where you think that 68% of values are within one standard deviation of the mean or 68% of the curve. So anyway, first of all, just lay out the number line, draw the curve above it. Use that as a visual. Looking at this visually then, and knowing the empirical rule for the normal distribution, could someone give me the answer that you can figure out in your head quickly to this question? What is the proportion of adult Americans having diastolic pressure less than 80.8, using the empirical rule for the normal distribution, and also knowing that it's a symmetric curve? So the value of 80.8 is one standard deviation above the mean. So looking at that, what percentage of the curve is in this gray area here? So we got a few answers. We got 80. Yeah, we got 84. We got 68. Yeah, we got 0.84. So we got a 68, but 84 is the answer. So any of you guys that actually said 84 would like to verbalize that? If you don't, did anyone want to say how they came up with 80.84 or 84%? Yaren?
Sure.
Thank you.
So just looking at the curve, knowing that the 65.2 would be the exact middle. So we're looking at, to the left of that point, we have 50% of the values. And then the remaining area that we have between 65.2 and 78.5 would be half of 68%, which is 34%. So adding those two up, we have 84.
Okay, great. Thank you very much. Yeah, thank you, Yaren. Sure. Appreciate it. That was excellent. So yeah, exactly. In the middle there is where 50% are below. Yeah, so you got 50% of values below the mean on a normal symmetric curve. You got 68% within 2 standard deviations, so there's 34 here and 34 here. Between here and here, from 51.9 to 78.5, is it? Yeah, 80.8. Sorry, yeah. We got 68% of values. So therefore you got 34 here and 34 here, each side of that. So yeah, so again, you have 50% below, and then you got 34 here, makes it 84. So again, it's just making use of the empirical rule. Well, a couple of things: the symmetry of the curve, knowing that, and then knowing the empirical rule, the 68 within 2, 1 standard deviation, 95 within 2. You can quickly answer that question. So that's 50% plus 34 is 84. Is there another way? Any other way? Another way is that everyone's underneath the hood. That's 100%. You know that 68% of values are within 1 standard deviation. In this area here, there's 16% left, because if 68% of values are within 1 standard deviation and it's a symmetric curve, you got 32 left beyond your 1 standard deviation above the mean or below. So this must be 16%. So everyone's underneath the hood, so 1 or 100% minus 16%, the white area, will give you the 84 too. So you could do it that way. The point of this is just to get familiar with this curve. This is a means to an end, is to get familiar with the characteristics of the curve and the distribution of it. You want to recognize that if the value that we're using in the question is a whole standard deviation or 2 or whatever, above or below the mean, you can make use of the empirical rule to quickly answer these sort of questions. So it's 84% of Americans, at least approximately, have diastolic blood pressures below 80.8, which is considered normal. So most people are in good shape, basically. What proportion of adult Americans have a diastolic pressure between 80 and 80.9? These values aren't whole standard deviations above or below the mean. So therefore, we have to take a different approach. What we have to do is convert these values to z-scores. The 80 and the 89. So our question is this. So again, remember, throughout this whole process of analysis, as I said at the beginning, again, these are tools for analysis, a process to get an answer. The answer that we're interested in is the process of getting it. It has a two-pronged approach in this scenario, that we get familiar with the normal curve for asking these sort of questions, but also, ultimately, and much even more important, being familiar with the normal curve is very important for statistical inference part of the course. All right, I can show it to you in a picture here, and again, it's a little small. You lay it out, knowing the empirical rule for the normal distribution. Good to draw it out to get used to this. Draw it out, mark off 1 standard deviation where you roughly think it would be for 68% of values within 1 standard deviation, 95 within 2. Mark it off like that. Then shade in the area you're interested in, 80 to 89. So you have an idea of what the probability is, or the proportion of the curve that you're trying to calculate. So that if you end up with something greater, say, than 0.5 or 50%, you know you're wrong. It's good to draw it out first. If this is all new to you, if you haven't done anything like this before, you're not so mathematical, draw it out and know that your values in the number line, and then a chunk of the curve within an interval on that number line is what you're interested in getting. Okay, so we have to do the conversion. And so it's the value. You have two values. We're looking for, again, this little shaded area here. You got the value minus the mean over the standard deviation, and that's our z-score. The value of 80 is almost 1 standard deviation above the mean. That's its meaning. 89 is the other one, the larger value in the interval, and the z-score is 1.62, meaning that our value of 89 is 1.62 standard deviations above the mean. And so you do that calculation, and you get your z-scores. So how would you go in terms of reasoning with that curve now? We've done a conversion. We've stripped away the units of measurements. Now we're just looking at this curve here. You know, you'll get the probability of getting a z-score less than 1.62 minus probability of getting a z-score less than 0.94. That's what we need to get. We're going to use the table for getting that. So the way to think of it visually, I want this piece of the chunk of the curve. So I would need the probability of getting a z-score less than 1.62 minus probability of getting a z-score less than 0.94. That's the approach we take to doing this. And we'll see why, because that's how the table works. They give you the area under the curve below a particular z-value, either negative or positive. For this one here, for the 1.62, we want to get that first. So we want to get the probability of getting a z-score less than 1.62. That's the first thing we need to get, because I said here, we need to get the probability of getting a z-score less than the 1.62, then get the probability of getting a z-score less than 0.94, and take away the second one from the first. So you go down here to 1.62, to one decimal place. That's the one decimal place, 1.6. Then up to here, 1.62 to 2 decimal places. That's as far as you'll have to go, to 2 decimal places. And there we have it to 4 decimal places. We got the probability of getting a z-score less than 1.62. And so we've got that as 0.9474. Then what's the other z-score we were looking at? 0.94. So let me just finish this off quickly. 0.94. We go back up here. 0.94. So that's the probability of getting a z-score less than 0.94. So 1 decimal place here, 2 decimal places up here, and then you just get the probability or the area underneath the curve below 0.94 in this case. We take the number we got for less than 1.62. Well, no, we get that. That minus this guy for less than 0.94 gives us our answer. 0.121. Thank you, Juliet. So that's the difference between those two numbers, and that's the area underneath this curve. We made the conversion, we got the z-scores, and then we reason with the table. The table always just gives, for whether it's positive or negative z-values, in this case positive, it gives you the area below that particular z-value on the curve. So therefore we work with the tools we have, and so we get the probability of getting a z-score. We get the probability of getting a z-score less than 1.62. We saw was 0.947 to 3 decimal places. 3 decimal places is fine. The probability of getting a z-score less than 0.994 was this, the 3 decimal places. And so basically these, again, don't get confused. These are proportions of the curve, and there are going to be values between 0 and 1 that you're reading from the table. These are values. So that can get confusing for some of you, that this is looks like a probability. No, this is a z-value. You've got values on a number line and probabilities, portions of the curve above it, which are always between 0 and 1. So again, everyone learns different, everyone thinks different. So just don't get confused by that. So yeah, we calculate both of those. We saw it. We have those, and then yes, one from the other, and we get 0.121. And so we went through a process of asking a question and answering it. We asked the question at the beginning, at least approximately, what is the proportion or percentage of adult Americans having a diastolic blood pressure in this range considered hypertension stage 1? And we can say, from what we did analysis, that approximately, as a proportion or a probability, or it's 0.12 multiplied by 100 to give us a percent, and approximately 12.1% of Americans are suffering from blood pressure hypertension stage 1.